Should we start, Nishant Korea?
Yes, ma'am.
You're not audible, Nishant. Uh, I think you are saying yes or something. Okay, so let's start. So actually, this is week 10, and the timing is 6 to 8 p.m., as you people already know. And here is my brief introduction. So I'm a research scholar from IISER Bhopal, and I had my MSc in Environment Management from Forest Research Institute, Dehradun, and BSc in Botany Honors from University of Delhi. And because I'm a PMRF research scholar right now, so I have some liability to teach 50 hours per year. So that's why I'm here to teach you. This is how we will proceed. Again, I have a lot of questions, and we will try to solve it with some kind of discussions. And I will request you people to communicate as much as possible. So for this week 10, I have basically three topics that we will discuss today. The first is we do have some practice examples. So we will try to solve the numerical questions, and we will see the formulas for different devices. Then we will try to understand what you mean by this air quality standard, and what pollutant we have, of which there are some standards. Then we will also talk about this emission standard. Then there are some regulations and legislation. We will talk about it. And yes, at the last, we will talk about the national policies and the program for managing ambient air quality. So these are the topic we will try to cover today. Uh, so these are the previous year questions, assignment questions. So we will take, I think, 5 minutes, not more than it, to solve this. And otherwise, we will solve new questions that I have created for you people. So this is first question, and this is numerical question, and I'm not forcing you people to solve right now if you don't have the pen and notebook with you. But yes, you people should know the formulas to solve it. Uh, Okay, so this question is whenever there is a gravitational settling chamber, okay, so for that, to settle it down, there should be the minimum size of the particle. So this question is based on calculating the minimum size of the particle that will be removed with 100% efficiency from the gravitational settling chamber under the flowing criteria. Uh, so for the air, we have the horizontal velocity, we do have the temperature value. For the particle, we do have the specific gravity value and the density of that particle. And for the chamber, the device that we are using in which the particle will be settled down. So for that, we have the length and the height. So, and we also have the viscosity of the air. So you have to calculate the minimum size of which we have the 100% efficiency. So can you try to solve it? If you people do have the pen and notebook, if you don't have, because only you three are here, so if you don't have, just write in the chat box that you don't have the pen, pencil, or notebook. Then we can go further. Otherwise, you can try to solve it. So there is a formula exactly on calculating the minimum size of the particle. Okay, Nishant gave me answer 59.2 micrometer. Okay. Okay, yes, I think I should not waste much time. Yes, the answer is 59.2 micrometer, and this question is based on this formula where D, that is the minimum size of the particle that you have to calculate, and this is equal to 18 multiplied by V. This is the horizontal velocity as it has been given, 1.1, then multiply by h. This is the height through which the particle travel before settling down, and this value already have given, that is 1.7. Then mu, this mu is the viscosity of the gas. This this already has been given. Then Lg, that is the length of the chamber, then the acceleration due to gravity, and the density of the particle and density of the air, and the square root of all of this. Then whenever you will calculate, the answer should be 59.2 micrometer, as Nishant already have given me right answer. I think I should not go right now on these questions because uh, it may be that you don't have the pen pencil. Okay, next question is the acceptable threshold level of the air pollution in term of its potential impact on health and environment is termed as air quality index, air quality standard, air quality value, air quality threshold. Nishant gave me B answer. Korea Muhammad Abdul, will you try for this question? Okay, you gave me answer D. Muhammad A. Not exactly. Nishan gave me right answer. That is B, air quality standard. And this is exactly the limit or the threshold level in terms of its potential impact on health and environment. For example, for sulfur dioxide, let's say, if it is less than 30 micrometer per meter cube, then the impact its impact on the human will be negligible. But if it is higher than this value, then impact on the human will be adverse. Okay, so whenever we are setting some limit, okay, whenever we have some threshold value, and this is known as the air quality standard. No doubt air quality threshold is very much similar to it, but no, the exact terminology for this is air quality standard. And if we talk about the air quality index, so this is not the threshold, but this is how much pollution you have in your atmosphere, in your environment, in your city. So, and this has been calculated into some values, 0 to 500. Okay, whenever we are just discussing how much value of that pollutant we have in our city or in our atmosphere or in environment, then it is the air quality index. Okay, so the answer should be air quality standard. We will talk about this as well. Okay, so as I told you, for some pollutant, we have some standards. We have some threshold value above to which we have some adverse impact. So you have to tell me, we have a national ambient air quality standard that has been released in 2009, and you have to tell me which pollutant was included in that revised list of these standard values. Nishan gave me A answer. So up to now, we have released three standard. The first in 1982, then it was revised. It was revised, and then it was again revised in 2009. So you have to tell me when it was revised. So what pollutant we have added in that revised list? You have to think. A is not the right answer. No, B is also not the answer. The pollutant which has been less explored was added later into the revised list. sulfur dioxide, nitrogen dioxide already has been explored much, and we did already know the impact of this on on humans. So we already had this pollutant in our list, but in the revised version we also included some different pollutant. This is nickel. Not sulfur dioxide, not nitrogen dioxide. I do have the list. I will show you in the next slide. Then you will better understand it. So answer should be nickel. Okay. So if a person observes a smoke emission using the Ringelmann chart and inferred 80% dense smoke, the corresponding Ringelmann number is. Nishant and Alka gave me a 4. That is D. Okay. So Ringelmann was one scientist who observed that the color of our smoke will relate to how much pollutant we have in this smoke, and based on that, he classified the color to some index number that is known as the Ringelmann number. So yes, answer should be 4. That is D. We will talk about this. I do have the slide for this. Okay, we have one act that serves as an umbrella act under which various rules and notification has been framed and issued to take care of different dimension of environmental challenges. Which act as a umbrella act? So we have 4 options: the Air Act, the Environment Act, a National Environment Tribunal Act, and National Environment Appellate Authority. Okay, Nishant and Alka gave me B answer. That is Environment Protection Act. Will you try Abdul Korea and I don't know how to pronounce that name, Babiyangor. Okay, yes. So everybody has given me answer B. So yes, this is Environment Protection Act that is in 1986. This is kind of umbrella act under which we will talk about air, we will talk about water, we will talk about the noise pollution, we will talk about the solid waste management. So this act serves as an umbrella act. Okay, so we have one policy, or you can say the program, that is GRAP. So you have to tell me the full form of this GRAP. Okay, everyone gave me D answer. So yes, this is graded response action plan. We will talk about this. What do you mean by this GRAP? What different characteristics we did take care under this GRAP? We will talk about this. Okay, so there is one program that is NCAP, National Clean Air Program, target reduction of 20 to 30% of particulate matter 2.5 and particulate matter 10 concentration by 2024 in comparison to the base year. So which year act as a base year? Alka gave me answer B, that is 2017. Gloria B, Muhammad B, Nishant, why you are giving me C answer? I don't know. But yes, every time there should be the base period to compare it. For example, since 2000, whatever the pollutant level we had in 2017, so how much we have reduced as comparison to the that baseline period. So for that we had the baseline period of 2017, not 19. So yes, the B answer is right. Okay, so that was the previous year question. I think you already have known the answer of it. So let's start with some different. So again, we do have the formula, and this formula is to calculate the minimum size of the particle that can be removed, and you have to tell me in which we have the L. So what do you mean by this L? Uh, Nishad, at the one time you gave me answer C and A. Okay, this is A. Okay, Nishan gave me answer A. Alka A or B? Korea A. Muhammad B. Uh, if we are talking about the particulate matter, then we assume that particulate matter is spherical in shape, right? And whenever we will talk about this, there should be the diameter or the radius of the particulate matter, not the length. So, because we are assuming that it is spherical in shape. So, B is not among the right answer. Then we do have, except it, you people gave me A answer, then yes, A is the right answer. That is the length of the chamber. So here we can see, like, this is the gravitational settling chamber, and we do have the raw gases. That raw gases have some particulate matter. Whenever this air or the gas will travel under this settling chamber, then the particulate matter will be settled down, and the settling velocity or the settling time of the particulate matter dependent on the dimension of the settling chamber and even the velocity with which our gas is moving. Okay, so here we had the D, that we need to calculate the minimum size of the particle so that we do have the 100% efficiency. Then we already talked about V, that is the horizontal velocity. A gas will move in the horizontal as well as downward. So we do have the horizontal as well as the vertical velocity. So V is the horizontal velocity. H is the height. So here we can see in this diagram as well. So H is the height through which the particulate travel before settling down. Mu is the viscosity. L is the length of the chamber. So the question was, what does this L mean? So this is the length of the chamber. Then G is the acceleration due to gravity, and we have mu, that is, I think we pronounce it as a mu. This is the density of particle, and we do have the density of the gases. So whenever we have these value, we can calculate what should be the minimum size of the particle that will definitely be settled down. Okay, so here L is the width of this uh, length of this chamber, or we can say width, not width but the length only. Okay. The next question is about the collection efficiency in the gravitational chamber only, settling chamber. So here there is a NC. So you have to tell me, what does it mean, NC? Alka gave C answer, that is number of trays. Nishan gave me C. Like in the last question, we saw that we calculated the minimum size of the particle. When we do, we will have the 100% efficiency. For example, we have the different size of the particle, and we have to calculate the efficiency with which the settling will be happened. Okay, so for that, like, we have a the minimum, there should or not be the minimum size of the particle. The particle may be, let's say, zero point 0.1 micrometer. Okay, so for that diameter, what will be the efficiency? As you people know that whenever there is a the size of that particle will be less, then the efficiency will be reduced. Okay, So based on the particle size, we will have some efficiency, even on based on some characteristics feature of that settling chamber itself. So NC means what? Nishant and Alka gave me C answer. Will you try? Korea, Abdul? Normality of the particulate matter, B. Not exactly Korea. Okay, this is number of trays. As we already know now, let me show you. Here we have the h, that is the height through which the particulate travel before settling down. So if we have the lesser value of h, that is the height, then we can increase our efficiency. In that formula, okay, we can see here, but this is like whenever we have the lesser height, then the efficiency will be improved. And for this lesser height, what we do, we insert some trays in that, so that height of that height of chamber can be reduced, so that settling can be happen very efficiently. So C should be the right answer, that is number of trays. So if you can see, like initially we had a very simple gravitational chamber, but right now we have number of trays that we have inserted in the gravitational chamber. Okay, so whenever we do have uh, the chambers, then the height will be reduced, and whenever height is reducing, then efficiency will also increase. Okay, so NC means the number of trays plus 1. So for example, here we have 4 trays, then the ANSI will be 4 plus 1, that is 5. Okay, next question is based on the cyclone separator. So for that, we do calculate the particle size with 50% efficiency. Okay, and again here you have to tell me B refers to what? Sham gave me A answer, that is the width of the cyclone inlet duct. Alka also gave me A answer, that is the width. Mohammed is little confused among A or B. Korea gave me A. Abdul, you should be sure about the A answer. So yes, Alka, A is the right answer. That is the width of the cyclone inlet duct. So this is the cyclone separator. So this is the structure, and we know that there is a tangent inlet duct from where the gas will enter, and then it will move in a circular motion. And because of that, we do have the inertia of the particulate matter that will strike to the periphery of the cyclone and will settle down. Okay, this is the principle of this cyclone precipitator, by which we can remove the particulate matter. And here B is the width of the cyclone inlet duct. So based on the width of this inlet duct, our efficiency will be dependent on this too. Okay, so now we will talk about the air quality standards. So my first question is, air quality standards issued by USA EPA. We have 4 major component, and you have to tell me what 4 component we are talking about. As I told you, for some pollutant, we do have some threshold value. Below to that, we do not have some adverse impact. Above to that, we do have the adverse impact on the human, on environment. Okay, so we have created some standard, and for that standard, we have 4 major component. So you have to tell me what these 4 different components we have. Nishant gave me answer A. You can have the example of, let's say, nitrogen dioxide. So to have some standard of nitrogen dioxide, what should be the four major component? Okay, Alka also gave me A answer. Korea A. Okay, so Mohammed also gave me a answer. So everyone gave me one answer only. So I will stick to that answer only. So yes, A is the right answer. So we have indicator, averaging time, form, and level. So as I told you, if we are having the example of nitrogen dioxide, so indicator is the pollutant. So of which pollutant you are talking about? So I'm talking about the nitrogen dioxide. So nitrogen dioxide is an indicator. Okay, then we are talking, so we are measuring the value of this nitrogen dioxide. We have measured it. So we have some value, quantitative value, as a threshold. As I told you, for example, if it is a 30 micrometer, a microgram per meter cube, below to it, we do not have the adverse impact. Above to it, we have the adverse impact. So we have value, let's say 30 microgram per meter cube. So this is the level. Okay, then we do have the averaging time. So that value 30 microgram per meter cube, that value should be calculated within some stipulated time. So for example, we calculated it for 24 hours. Let's say for the monthly value, this value should not exceed. So averaging time, what it is? It is annually, or it is hourly, or it is daily. So this is the averaging time. Then the form. So I have one slide. Yes. So for example, if it is an indicator, then it will define what to be measured. For example, particulate matter 2.5, SOx or ozone. Then averaging time, it may be like you are calculating your value for how much time period, for 1 hour, for 8 hours, for 24 hours. So that will be like that. Then the form. So there should be some statistical method. For example, we do have, whenever we are not exceeding it, so we are calculating it 104 times per year. Okay, we are calculating the value of particulate matter 2.5. Let's say for the duration of 24 hours, and we are calculating it 104 times per year, and whenever it will exceed to it twice, then we will call it as a, we are not we are not abiding with that level. So this is the statistical method. Then the level. So as I told you, we have the some quantitative value, so that will be the level. So these are the four major components. Yes, here we can see that if it is the carbon monoxide, then this is the pollutant or the indicator. Averaging time, for how much time period we are estimating it, 8 hours or 1 hour. Then the level, what threshold level we have, and then the form, not to be exceeded more than once per year. So this is the form. So we have the four major components. Okay, which indicator has the averaging time of 1 hour and 8 hours? So we have multiple indicators, for example, SOx, for example, NOx, ozone, carbon monoxide, particulate matters. So for most of the indicators, we do have the averaging time of annual or 24 hours. Okay, but we do have two indicators of which the averaging time is 1 hour and 8 hours. So you have to tell me the pollutant. Nishant B, Alka B maybe. Be sure about B, Alka. Will you try, Karya? Abdul? Okay. B. Okay, yes, B is the right answer. Yes, B is the right answer. That is ozone and carbon monoxide. And because we are calculating, we are having the threshold or a threshold for this ozone and the carbon monoxide for the short period. Uh, if you know that if we are having the sulfur dioxide or the nitrogen dioxide for 1 hour, or let's say for 8 hours, we may not have the adverse impact. But for the case of the ozone and the carbon monoxide, this short term concentration can also lead to some response in your lungs. Okay, that may have the adverse impact. So even for the 1 hour and 8 hour concentration value of that particular pollutant, we will have some impact. That's why we do have the threshold value for this ozone and carbon monoxide for 1 hour and also as for the 8 hours. Okay, so these are the exceptional. Otherwise, most of these values are for 24 hours and for this annual. Okay, here we can see like we do have the pollutant, sulfur dioxide, nitrogen dioxide, particulate matter, ozone, and of which we do have some threshold value. Above to that, there will be impact on us. Okay, and if you see the carbon monoxide, we do have two value, one for 8 hour and one for 1 hour. And same for the ozone, we do have the value for 8 hours and the 1 hour. Okay, so otherwise we do have the value for annually and for the 24 hours. Okay, which indicator is mass based without regard for their chemical composition? Nishant is so quick to give me the answer. C, that is the particulate matter. Korea, C. Okay, C. Alka, what's your answer? C, no idea. I'm guessing only that question. Okay, yes, C is the right answer. That is the particulate matter. And why it is? If you know that for the carbon monoxide, you know the carboxyglobemia. So what it is? This is because of the structure of the carbon monoxide, the efficiency to attach with the hemoglobin is very high. Because of that, there will be the insufficient oxygen in our body, and that will that because of that you may also suffer from the death, right? So this is the chemical composition on which based on that we do have the adverse impact of this carbon monoxide, right? But for the particulate matter, chemical composition doesn't matter much. Right now we are studying about the chemical composition because it may be methane, it may be some different salt that are making this particulate matter. But right now the most of the study is based on this mass based. So what concentration of this particulate matter we have in our atmosphere, irrespective of its chemical composition. So for example, in the winter time or even in the stubble burning in Punjab and Haryana, there is a particulate matter in the atmosphere. We are not talking about the composition of this particulate matter. Just what we are talking about is how much particulate matter we have in the atmosphere, and because of that there is the visibility problem. Because of that there is because of that it can be the carrier of this condensation nuclei, can be act as a condensation nuclei. So we are not talking about the chemical composition of the particulate matter, but we are talking about its mass only. So this is the only pollutant of which we basically narrate this chemical for this mass based, but not for the chemical composition. Okay, so we do have some standards, right? We do have some threshold for this for each pollutant. So what factor we did consider to set such kind of air quality standard? So adverse impact on health, spatial population at risk, dose response cover, exposure characterization, risk assessment, unacceptability of risk. So you have to tell me the correct things. Alka is so quick to give me the answer C. Okay. Okay, Alka. Maybe C. Okay, let's see. C. Okay, three of you have given me answer C. Then obviously C is the right answer because uh, that sixth one, unacceptability of risk, that should be the acceptability of risk. And these are the factors that we have to consider before setting up that standard for this air quality. So yes, these all except these six are the right answers. So C is the right answer. Okay, so we do have some standards in India that has been adopted by CPCB. So you have to tell me when these standards were adopted initially, then they were revised, and they were again revised. So you have to tell me 3 years. When they were adopted, then revised, then again revised. Nishant gave me answer A. Alka A. Abdul A. Korea, you also want to try? Okay, A. Everyone gave me answer A, then obviously answer should be A. So for 1994, so initially in 1982 we had some standard. Then these standards were revised, and we had another list that has been released in 1994, and then that list was again revised, and this has been released in 2009. So for 1994 we had these pollutants: sulfur dioxide, nitrogen dioxide, suspended particulate matter, respirable particulate matter, lead, carbon monoxide, and ammonia. For that, we have the averaging time were annual and 24 hours. And for the carbon monoxide, it was 8 hour and 1 hour. Then the concentration value has been divided into two columns. The one is for the industrial value, and second is for the residential, rural, and the another area. Sorry, for the three columns, and another for the sensitive area. So this was the standard list that has been released in 1994. Okay. Then in 2009, the list has been expanded. Some different pollutant has been added into it, And if we can see right now, we have values for 2 columns, not for the 3 columns. So for the first column, we have values for the industrial, residential, rural, and another areas. And the another value is for the ecological sensitive areas. So the list has been expanded, and even we did change the value based on some new processor, based on some new type of experiment we did. Okay. The question right now is, as I showed you this two tables for this 1994 and for 2009, so you have to tell me how much pollutant we considered in this standard for 1994 and for 2009. How much pollutant we considered in 1994 and how much pollutant in 2009. Alka, Nishant, will you try? Nishant B. 7 in 2000 in 1994 and 12 in 2009. Can you count? This is 1994 and this is 2009. Now, can you tell me the answer? Have you calculated? Have you counted? Muhammad A. Count this. Is it 8 or 7 in 1994? Okay. What should be the answer now? You can correct yourself. This is not the examination. You can correct anytime. Alka gave me B answer. Nishant gave me B. Korea B. Okay, Abdul gave me the B answer. Then we can proceed. Yes. So yes, it is B because in 19 yes. So we have 7. SOx, NOx, suspended particulate matter, respirable particulate matter, LAT, carbon monoxide, and ammonia. These were 7. Then we added and we also replaced some, and now we have the 12 pollutant, of which we do have the values. And if we are violating these values, then there may be some punishment, obviously we are not liable for the punishment, but yes, if some industry are emitted something, then we will talk about this as well again. So yes, answer should be B. Okay, so again we are comparing this national ambient air quality standard of 1994 and 2009, and there are some statements. You have to tell me the correct statement. So first is, suspended particulate matter as parameter has been replaced by fine particulate matter. The second option is, suspended particulate matter as parameter has been replaced by coarse particulate matter. Other new parameter like magnesium, aluminium has been added, and residential and commercial areas kept separated in revised one. What do you think? What is the right answer? Should I show you again this? This was the first. And this is your second list. And based on that, we have this question. Nishant gave me A answer. What changes we did from 1994 to 2009? What were the changes? We saw that we added some new pollutant from 7 to 12 we had, but some other changes were also included in 2009. What were they? So do we have magnesium and aluminium in our list? No, it is not. And then I told you initially we had 3 columns, and right now we have 2 columns. Uh, Initially, we had 3 columns, one for industrial, second for residential, third for sensitive areas. And for 2009, we do have 2 columns. Then this third and fourth is not the right answer. Then you have two right now, one and second. So you can guess now. Yes, A is the right answer because the suspended particulate matter as a parameter has been replaced by fine particulate matter, not the coarse particulate matter. Because if we are talking about the suspended particulate matter, then yes, we are talking about the fine particulate matter. So we replaced it with the fine particulate, that is the 2.5. So is the right answer. So here we can see 5 major changes we did from 1994 to 2009. So what these changes were, as I told you, initially, because in the industrial areas as well, we do have the humans, we do have the animals, we do have the plants. Okay, so whatever the standard we do have for the residential area, that standard should be complied for these industrial areas. That's why we merged these 2 columns into 1 column. First change was this one. Second, a more stringent limit were applied for this LAD, SOx, and NOx. Uh, Initially it was a loose limit. Then we strict the limits with changing the values from higher to lower values. Then we replaced suspended particulate matter with fine particulate matter 2.5. Then we added new parameters such as ozone, arsenic, nickel, benzene, and the benzopyrene in 2009 list as comparison to 1994. Then we also have some standard for the short duration, because for the short duration they may have the peak exposure, and that can also give you the adverse impact. So for example, ozone and the carbon monoxide, we do have the standard for the short duration for 1 hour and for the 8 hours. So these 5 changes we had in 2009. Okay, so for India, we have the facilities to conduct the experiment, and based on that, we formulated our standards. Okay, but for the least developing country, for example, for the African countries, these countries doesn't have their own standard. Okay, for them, WHO, that is World Health Organization, gives the guidelines for this standard values for air quality standard values. And again, you have to tell me when WHO, that is World Health Organization, uh, established such guidelines, and then it also revised it into some years. So you have to tell me when these guidelines were released and then when it was revised. Alka A 2005 and then in 2021. Maybe, okay. There is no problem even if you are giving me wrong answer. You are participating, that's enough for me. Ishant Mohammed, A or B? Okay. I'm unable to pronounce that person name that is starting from B, so that's why I'm not saying anything to you. Okay, so answer is A. So it is 2005 and 2021. Okay, so WHO released revised air quality standard on September 22 in 2021, and it was major update to this standard in 15 years. So initially it was in 2005, then WHO revised the list in 2021. Okay, then okay, so here we can see, like for 2005, here we can see we have six pollutant: particulate matter 2.5, 10, ozone, nitrogen dioxide, sulfur dioxide, and the carbon monoxide. For these seven pollutant, we have some values for 2005 and for 2021. Okay, and you have to keep in mind that for every country, the topography is different. The climate pattern is changed. Even the industrial structure is different from one country to different country. So it may or may not be perfect for your country. The guidelines that has been given by WHO. So it is always better to have your own standards, but if you do not have, then you can stick to WHO guidelines. Okay, so these were the guidelines for the six pollutant. So next, my question is, by WHO, air quality guidelines 2005 for the SOx was 20 microgram per meter cube, which further increased or decreased to what value? As I show you in the last slide, this. Nishan, give me B, increased to 40. Are you, Nishant, is it mean that you are diluting the standards? Because if you are exceeding the value, means you are diluting, you are not giving it a tight standard value. Is it right? Alka B, uh, that for 2021, the value increased and increased to 40. Okay, we can say. Yes, you are right. That for 2005, initially the value was 20. So we had a threshold value 20, below which there were no impact, and above which we do have the impact. But in 2021, this has been increased to 40. Below that we do not have any impact, and above that we do have the impact, and this is based on like as per the advanced experimental values. As we advanced into the study, we got to know that up to 40 we can bear this value, we do not have the impact, so we can increase this value from 20 to 40. So yes, B should be the right answer. Okay, you people already know about it, but you can give me the answer. This is the kind of definition. So that one define release limit that are usually measured directly at your sources. अलका टेबल लर्न नहीं करना होगा, लेकिन कुछ फैक्ट्स तुम्हें याद करना पड़ेगा, लाइक हाउ मच पोल्यूटेंट वी आर टेकिंग इन टू कंसिडर एंड सम अनोमली वैल्यू, as I told you, like for some we increase the value for sulfur dioxide, and uh, what pollutant we added in Indian standard from 1994 to 2009. So you should know, like and this is actually important if you are preparing for the UGC environment net examination. Then yes, one question is always asked from this 2009 revised list of this NAQS. So they basically ask about this uh, nickel or sulfur or nitrogen, and what's the value for that. So if you are preparing for the UGC environmental net or something, so you have to learn the revised table. So for example, for 2009, most of the time such kind of exam doesn't ask you question for this WHO, but yes, they will ask you question from this national ambient air quality standard that has been adapted by CTCB. Okay, so yes, so for example, we are taking the example of Delhi. Okay, so for the Delhi, we know that for, let's say, carbon monoxide, we do have some value and we have some standards. Okay, but we do not have any role. We just have some value of it. Okay, so because of that, we also created some standard. Uh, at the source value. For example, if it is a vehicle, then we have some standards. Uh, Above to that, we can't release that much pollutant. For the industries, for example, if we have the hydroelectrical industry, so for that industry cannot exceed some limit of the particulate matter or for different kind of pollutant. So now we are creating the standard at the source, not in the atmosphere, but at the source. So what it will be? Mm, Nishan gave me C and Alka C. Okay, so this is C, that is the emission standard. So what is the threshold up to which you can emit? For example, from the vehicle, for example, from the industries, from mining area. So we do have some standard of the emissions. So emission standard define release limit, how much you can release into your atmosphere, which were usually measured directly at their source. So right now we are talking about the measure standard, and you can keep into your mind the vehicle. For example, if you are driving the car or let's say bike, then how much pollutant you can release into the atmosphere. You know that there should be some certificate that you have to have, that are being checked by the police. So these are basically based on this emission standard. So how much pollutant you are emitting from your vehicle. So this is the emission standard. uh, Here we have, like, the source include tailpipe emission from car and trucks, stack emission from factories and power plants, and general air emission from domestic sources. And India have initiated to follow emission standard through the Motor Vehicle Act of 1988. And this is not that much important right now. So this was the emission standard. To control the emission from the source, we have some standard that is known as the BS standard or the Bharat stage. So again, you have to tell me, initially we have the BS1, and right now we are implementing the BS6 standards. So you have to tell me when these standards were implemented. When this Bharat Stage 6 came into force, based on that you can you can have some estimation. C maybe. Okay. A or C. Okay. Abdul, you can go for the intersect. Like what the answer of Alka. So you can intersect your answer with Alka. So I think you can get the right answer among this A and C. Okay. Anyway, so answer is C, that is 2000 and 2020. So right now we do have implemented five Bharat stage. So and it has been taken from the European emission standard. So first was implemented in 2000, then 2005, then 2010, then 2017, and when we saw that we can directly jump on sixth. We didn't implement the fifth BS standard, but we directly jumped onto the sixth standard. So for in 2017 we had the Bharat stage 4, and for 20 we had directly 6. And can you see? Yes, if we see, whenever we are applying such norms, BS 1, 2, 3, 4, if we are seeing that particulate matter that has been released has been decreased significantly over the time. So and if you people know that whenever we are talking about the Bharat stage, then we are modifying the engine, we are modifying the vehicular structure in such a way that combustion that is happening within your vehicle is so efficiently done in such a way that the pollution emitted is very low. Okay, not just we are modifying the engine, but we are modifying like we are improving a lot of technology, we are scrapping out the outdated vehicles. So this is such kind of changes are implementing like from BS1 to right now to BS6. Okay, so while modifying the body structure, the engine structure, the stroke, the accelerator, so whenever we are changing into that, the combustion has been improved. Okay, and based on that, the particulate matter, the carbon monoxide has been released, decreased significantly. Okay, so time to time we are having the modification in our vehicle, and based on that, uh, the emission of this pollutant has been reduced. Here we can see, like, and for different vehicle we do have the different standards as well. So for example, if it is a petroleum distillate vehicle, for that you have different value for the nitrogen dioxide, how much you can release into the atmosphere. For the particulate matter it is different. For the diesel fuel vehicle we have some limit for different pollutant differently. Okay, so and these value has been very strict time to time. Okay, okay, which is the first act of independent India indirectly focusing on air pollution? Nishan, give me B answer. Factories Act. Alka, what do you think? What should be the answer? Korea, Abdul, Jack Krishnan. Stafford. Okay, so B is the right answer. That is Factories Act. So we do have the legislation and regulation that happened time to time. So for example, from 1905, we had first act, that was the Bengal Smoke Nuisance Act, and this act was based on we had British had some monument, and because of the chimneys, because of the combustion, these monuments were degraded. Okay, because of that pollution. Based on that, British at that time uh, legislated the act, that is the Bengal Smoke Nuisance Act. Based on that, they just regulated on the combustion activities in the chimneys. Okay, then we had then Bombay Smoke Nuisance Act, just like Bengal. Then we had the Motor Vehicle Act, based on some standards. Then because we got freedom in 1947, so yes, Factory Act was the first act that has been that was related to the air pollution, and just after our independence in 1948. Then we had the Industrial Act, Inflammable Substance Act, Mine Act, Atomic Energy, and then Gujarat Smoke in 1963. And uh, below this was the list that we are not taking care much, but after that, from 1981 to 2022, we had very significant legislation, and based on that, we are trying to control the pollution level, right? Then yes, again, Ringelmann chart is used as a device for determining whether emission of smoke in which act. Bombay, Gujarat, Factories Act, Industry Act. Nishan gave me B answer. How is it possible, Nishan, that you are giving me the right answers? Are you studying so hard, or you know without studying it? Anyway. Okay, so the answer is Gujarat Smoke, and here I have something about this. So Ringelmann devised a visual assessment method, means by visualization, by seeing the color of the smoke, you can estimate whether this smoke is under the is under the standard or not. Okay, so this he devised a visual assessment method for smoke emission by comparing the darkness of smoke with standard shade of gray on the chart placed in a suitable position. And here I show you. Yes, here so the scale was from 0 to 5, and if it is if smoke color is so transparent or the clear, then we will call it as a it is not much of our concern. Then the color, if it is if there is a how much opacity we have, it is a 20%, 40%, 80%, 100%. Based on that, we are just devising the emission level. Okay, so there was one question now, based on if there is a 80% opacity, so barely transparent, so means the color is going to be black, so the smoke color is going to be black, or it is from grayish to black color, then the scale will be the Ringelmann 4. Okay, this is very much easy question. So we have 4 acts that are so important to us: Air Act, Motor Act, Environment Act, and the Water Act. And you have to tell me when this act were legislated. I think this is last or second last question that is based on the years. I know identifying or just reminding the year in your mind is little bit difficult, but these were some question I will try. Next question were not based on that much on years. Nishant, C or D? Mohammed C. Nishant, you can intersect your answer with Abdul, then you will get the right answer. I think not exactly, but yes, you can have the right answer then. Come on, guys. This is the simplest question ever. Air Act, Water Act, Environment Act. Water Act may be little bit difficult for you, but yes, you can tell me. Korea gave me C answer. Alka, what do you think? Are you confused? Okay, so the answer should be C. So Air Act came into force after Water Act, right? So initially we had the Water Act in 1974, then we had the Air Act 1981, then we had the Environment Act in 1986, and much before that we had the Water Act in 1939. So C is the right answer. Okay, this is very much important. National Green Tribunal Act was enacted in. What Korea revised the answer? What? I couldn't understand. For previous question, for Air Act was in 1981. Motor Act was 1939. Yes. Third is for A. Yes. Uh, this is right. C should be the right answer only. Okay. NGT. This is very much important. So whenever there is kind of pollution in the Delhi, so anyone can go in the court. Not that Supreme Court or High Court. That court is known as the National Green Tribunal. Okay, where you can go and you can complain about the industry, and if that industry is violating some rules, then there will be the compensatory monetary values they have to give to the government or to the court. Based on that, you can conserve or reserve your natural beauties. Okay, so this is very much important. Whenever there is a debate among the economic value and the natural values, then you can go in NGT and you can complain. Whenever you are thinking that the smoke near to your home is so high, then you can go and complain, and based on that, like there will be fine will be imposed on that industry or that company. So this is very much important. So when it was enacted, this act, uh, Nishan gave me A answer, that is 2010. Okay, so answer will be A, that is 2010. So it was established in 2010, and this is specialized judicial body equipped with expertise solely for the purpose of solving environmental cases in the country. The tribunal is tasked with providing effective and expeditious remedy in cases related to the environmental protection, conservation of forest and other natural resources, and enforcement of any legal right related to the environment. Uh, so this is very much important, and this has been established in 2010. This is the current GK question. So who is the current chairman of NGT? As like Supreme Court. So who is the Chief Justice of the Supreme Court? So you should know about the current chairman of NGT. Can you quickly search and tell me? You have time. Korea has the phone in his hand, so that's why he's so quick to search for it, I think. Who is the current chairman of the NGT? NGT is National Green Tribunal. So, National Green Tribunal, it is a judicial body, just like Supreme Court or High Court, where the cases related to the environment are solved. So there is a chairman. So you have to tell me the name of the current chairman of NGT, just like the Supreme Court Chief Justice. Ishan didn't research yet. The current chairman of NGT, Alka, Jack Krishnanan. Okay, so answer is yes, Nishant. It is A. That is Justice Prakash Srivastava. So right now he is the current chairman of NGT. Yes, Abdul, it is A. Okay, this is again the year question. So when this CPCB was established? Nishan gave me B answer. 1974. So in India, first Korea also gave me B answer. So in 1974, there was one act that was enacted in India. What was it? Air or water?
Water, ma'am.
After that act only, CPCB was established. Jack Krishnan also gave me B answer, 1974. Yes, B. Korea, no, it was Water Act. So there was some awareness about the water, waste water, and the polluted water. So based on that, first act was the Water Act, 1974, and based on that, CPCB was established within that year only in 1974. Then CPCB gave the suggestion for this Air Act in 1981. And then there was the Umbrella Act, that was the Environment Act in 1986. So, yes. So in 1974, CPCB was established under Water Act, not the Air Act. Okay, again question for the year. So you people know about the AQI, Air Quality Index. So when it was established? And how do you calculate this AQI? First question is when the methodology for this AQI was established. I'm not gonna waste much time on this. So it is 2014 when the methodology for this AQI was established. So if you know that we have the AQI value ranging from 0 to 500, right? And based on that, we can categorize whether, based on this index value, we can categorize whether our air quality is good or not for us to go out. Okay, and how this value are calculated. So we do have measure 8 pollutant based on which we calculate the AQI, and these 8 major pollutant are particulate matter, then carbon monoxide, ozone, nitrogen dioxide, this is sulfur dioxide, then ammonia and lead. And for the particulate matter, it is 10 and 2.5. That's why the numbering here is 7. But yes, these are the 8 major pollutant based on which we calculate the AQI, and the formula for that AQI is like this. So for each pollutant, we do have some breakpoint concentration, and based on that, we do have some AQI value for that particular pollutant, and whichever the AQI sub index of that particular pollutant higher, then we will consider that AQI. So for example, this is for the sub index. So I show you. So for the particulate matter, we can see we have the AQI only for the particulate matter. Likewise, for the carbon monoxide, we have different AQI. For the nitrogen dioxide, we have different AQI. And this is not the AQI, but these are the sub indices. Okay. And so we can see for each pollutant, we have sub indices, sub AQI indices, and for some particular pollutant concentration. So for example, you want to calculate, if we do have the concentration of particulate matter 10, that is 85, and here we can see the higher value and the lower value are 150, then the corresponding value of the sub indices is 100 to 50. Then you can calculate the sub index for this, and for 8 pollutant, we will calculate 8 sub indices, and which one will be the higher will be considered as the AQI index. Okay, so this is how we calculate the AQI, that is the air quality index. Okay, so right now we will talk about the programs. So we have different type of program, that is NAMP, we have CAP, we have NCAP. So we will talk about these kind of program, what kind of facility such kind of program provides to us. So this is about the NAMP, that is National Air Quality Monitoring Program. So you have to tell me the correct statement. And the first statement is, initially it was named as National Ambient Air Quality Monitoring, NAAQM. This program started in year 1984 with 7 stations at Agra and Delhi. In year 2019, the number of stations were raised to 805. One objective is to ascertain whether the prescribed ambient air quality standard are met or violated. So you have to tell me correct statement about NAMP, that is National Air Quality Monitoring Program. Nishan, give me answer A, first and second. No. So what was the objective of this NAMP? Is it not the fourth option? There should be some objective of that particular program. And you can see like it is the air quality monitoring. So we did installed some station at some point at some places. So for what? There should be some objective of that. And based on that, you can tell me the answer. C, first and fourth. Nishad, do you think that fourth, that the objective is to ascertain whether the prescribed ambient air quality standard are met or violated? Literally, it is objective or not for this NAMP. We do have the standard, as we already talked about it, but whether cities are violating it or not, so this can be only done when we do have the monitoring station. Then yes, fourth should be the answer. Like objective is right, then you can select the answer. Okay, so the C answer is right. It was initially named as National Ambient Air Quality Monitoring. And this program started, yes, it was started in 1984 with 7 stations. It was right, but at the Agra, but not at the Delhi. Okay, so station initially were in Agra and at some place I will show you. And then in 2019, I just tweaked the number. It was 804, not 805. So here we can see, like in 1984, we had the 7th station at Agra and Anpara. And in 2019, number of stations were raised to 804, and that covered 344 cities in 28 states and 6 UTs as on 31st December 2019. And you can see, like, a lot of station has been installed over the India, and the objective were these. The first objective was to ascertain whether the prescribed ambient air quality standard are met or not. Then to identify which cities are not are not complying to the standard, which cities are violating the standard. So to identify non-attainment cities. Then to obtain the knowledge and understanding necessary for the developing preventive and the corrective measures. So if we will know which country is violating again and again, then yes, we can try to understand what can be the prevention method for that. And then to understand the natural cleansing process. For one place there may be, like, at two places there may be 50-50 industry, but at one place there are not much pollution level, but at another place there is a much pollution level. Means at first place there must be natural cleansing processing. For example, the wind speed or the temperature or the dispersion is so high, so you have to understand it. So based on your monitoring station, you can go through such objectives, right? Okay. So, which three air pollutant has been monitored regularly by CPCB at all the location under the NAMP, the program we talked just recently? Not all the gases, not all the pollutant has been monitored regularly, but yes, there were three pollutant that has been monitored regularly at all stations. So, what were they? Nishan gave me uh, uh, is it difficult, like among particulate matter 10 and matter 2.5, which one is easy to calculate? Based on that, you can get the right answer. Yes, based on that, you can get the right answer. Okay, right now, Nishant have the option A. Jack Krishnan, Korea, Alka. Alka, where are you? You are not giving me the answers. Okay, A was the answer because it was started in starting since 1984. Na, so stations. I show you. So this program was started in year 1984 with 7 stations, and That time, there were not much discrimination about particulate matter 10 and 2.5, and we didn't have much technology to identify, to know the concentration of particulate matter 2.5. Even we didn't know that 2.5 particulate matter are much dangerous for us as comparison to particulate matter 10. So we had only three pollutants, that were sulfur dioxide, nitrogen dioxide, and particulate matter 10, that were monitored regularly at all the location under the NAMP. Okay, so sulfur dioxide, this and this, and even with that, we are also measuring or monitoring the meteorological parameters such as wind speed and direction, relative humidity and temperature. These were such kind of meteorological parameters are also monitored at some selected location where we do have the facility of that. Okay, the next question is about the graph. So right now we are talking about the program. So we talked about NAMP, and right now the question is about the graph. So I have some statement and you have to tell me the right statement. So it is graded React action plan. It notified on January 12, 2018. It is for the prevention, control and abatement of air pollution over India, and it involves the ban on construction activities, shutting of school, closure of brick kilns, etc. are some of the measures that we take. So you have to tell me the graph. Nishant gave me B answer. That is only fourth. Jayakrishnan C, second and third. Answer is only fourth. Can you tell me the full form of graph? Graded. Instead of react, there is something different. What is it?
Response.
Nishant, your voice is not audible to me. I think you have muted yourself. You are trying to say something. Yes, it is response. Graded response action plan. And yes. So, yes, it was notified on January 12, 2017, and it is graded response action plan. And this was just for Delhi, not for over the India. So I wrote here over India. No, this was just for Delhi, not for India. So that's why this third was not the right answer. And instead of react, it was response. So first was also not the answer. So second was the right, and third, yes, it involves the ban on construction activity, shutting of air, and why it is graded. So you have to understand, as it is graded response action plan, means grading. We do the grading. So for example, we do have the AQI. Based on AQI value, we can respond and we can act. For example, if our AQI value is between 0 to 200, then the response will be different. But if our AQI value is from 200 to 300, then our response will be different. And if it is higher than 400, then the response will be different. So for example, whenever there is a higher value, more than 400 value in Delhi of this AQI, then we have to shut the schools, we have to close the schools. So the children are not allowed to go out from the home. Even most of the transportation, the truck transportations are not allowed when the AQI exceed 400. So this is graded, means based on whatever the air quality value we have, based on that we have different kind of step we do take. Okay, so and these steps may be prohibition on entry of truck, ban on construction and activities, in introduction of odd and even scheme for private vehicles, shutting of school, closure of brick kilns, hot mix plants and stone crusher. Next slide I had to have. Yes, so we do have four stages because it is graded. Okay, so for one stage, when our air quality is moderate to poor, so when our particulate matter is above 61 and a particulate matter is above 101, so we do have different type of response and action. For example, we will have the ban on the firecrackers, but stage 2 means the air quality is very poor. Then we will ban on the diesel generators. If it is a stage 3, means the particulate matter is above 250 or the particulate matter 10 is above 430, then increase frequency of road cleaning and washing. We will shut down of the brick kilns. There will be the restriction on the operation of coal based plant in NCR. And if it is a fourth, means there is kind of emergency, the value has been exceeded much and there will be higher level of response that we will take in Delhi. And this is just for Delhi, not for over the India. So this is GRAP, that is Graded Response Action Plan. Okay, the next program is High Level Task Force. So you have to tell me the correct statement for this. It was constituted in November 2017. It was for managing the air pollution in Delhi and NCR. It is to for the closely monitoring implementation activity related to the air pollution. What should be the right answer? This is the next program, that is HLTF, High Level Task Force. That is right. Like it was constituted in November 2017 only. No more playing with the dates. Whether it is for Delhi and NCR or over the India, the first confusion. Second, is it for closely monitoring the implementation of some activities that is related to the air pollution? What do you think? Maria, Nishant, Jack, Krishnan, Alka. Abdul, Stapwer. Guys, come on. Yes, Nishant, or is the right answer. Okay, so all of the above is the right answer because this was constituted in November 2017 under the chairmanship of principal secretary to the Prime Minister of India, and it was managing the air pollution in Delhi and NCR. And uh, it was related to see whatever the activities we are having in Delhi to control the air pollution, are we going in the right direction or not? The activities that we are having to control this air pollution, is it in right direction or not? So this was related to that. So most of the time there is a regular review meeting to review whether the steps that we are taking are right or not. So this is kind of regular review meetings are held during the year with all concerned central government ministries and the state government under the chairmanship of Honorable Minister as well as Secretary, EF and CC to ensure that various measures for prevention, control and mitigation of air pollution in NCR Delhi are taken in the coordinated and the effective manner. Okay, the next program is CAP. So there are also some statement, and you have to tell me the right statement. So it is Capital Action Plan. It identifies timelines and the implementing agencies for action identified for the prevention, control, and mitigation of air pollution in Delhi and NCR. The central government notified CAP in 2018. I'm not playing with the dates. Only CPCB have been directed under Section 3 and 5 of EPA, that is the Environment Protection Act 1986, to ensure strict implementation of comprehensive action plan. What do you think? What is the right answer? This is the next program, that is CAP. Alka Nishant, Jai Krishnan, Korea, Stepper, did you try? Or do you know, you don't know about this CAP? In the last line, there is a full form of this CAP. Korea C, third and fourth. Only word is dangerous. How you can think? Okay, anyway, answer is second and third. We'll see about this. So this is comprehensive action plan, and it was implemented in 2018. And it do identify timelines and the implementing agencies. So what different agencies can work and what should be the timelines to control this air pollution in Delhi and NCR. So there are 55 agencies that has been directed, not just the CPCB, but 55 agencies has been directed to ensure strict implementation of CAP, that is the Comprehensive Action Plan. And these 55 agencies include Ministry of Petroleum and Natural Gas, Ministry of Road Transport and Highways, Ministry of Housing and Urban, because each of the ministry may contribute in controlling the air pollution, right? So that's why this comprehensive action plan identify which agency can work to control the air pollution, the first thing, and what should be the timeline for that. So we do have different ministries and the agencies that can work together to control the air pollution. And this is just in Delhi and the NCR. Okay, next is about the NCAP. So again, you have to tell me the right statement. So it is National Comprehensive Action Plan. The goal of ANCAP is to meet the prescribed annual average ambient air quality standard at all locations in the country, not only in Delhi. It is a mid-term action plan to begin with, keeping 2017 as the base year. The tentative national level target of 20 to 30% reduction of carbon monoxide concentration by 2024 is proposed under ANCAP. You have to tell me again the right options. Nishan gave me C answer, third and fourth. Don't confuse with the country. It may be that this ANCAP is for the all over the India, not for the NCR. Jai Krishnan B, second and third. More answer? Okay, so B is the right answer, second and third. And uh, you can like this is for all over the India and cap because this is national. Okay, so and this is not the comprehensive action plan. This is clean. You will see. I have some slide for this. Okay, so this is National Clean Air Program implemented in 2019 under the Central Sector Control of Pollution Scheme, and the goal is to meet the prescribed annual average ambient air quality standard at all location in the country. And here again, baseline period was 2017, and it was said that the reduction of particulate matter 2.5 and 10, not the carbon monoxide, as I wrote here, the carbon monoxide. So the reduction of 20 to 30% of particulate matter 2.5 and 2.10 by 2024, keeping the baseline period 2017, and it can be extended further to 20 to 25 years. And this is all like and overall objective of this ANCAP: anticipate comprehensive management plan for prevention, control and abatement of air pollution beside augment of air quality monitoring network across the country. So can you tell me, like, we explored a lot of programs, so can you tell me which program was just focused over the India, not the Delhi and NCR. So for all over the India, the program was implemented. So one is ANCAP, another is, can you tell me the name of one another program that has been implemented across the India, not just for Delhi or NCR? Anyway, I think I do have second last question. It is, so among NAMP, GRAP, HLTF, CAP, and CAP, which programs are just to tackle the pollution problem in Delhi and NCR? This is last second question. As we talked about all this program, NAMP, GRAP, HLTF, CAP, and CAP. So you have to identify which program is focusing just over Delhi and NCR, not across the India. Can you guess, Nishant? Korea, Jack Krishnan, Alka, Abdul, Stapfer. We talked about all these programs. Okay, the hint is whenever there is a national, then it will be across the India, and if it is not national, then Delhi will be only the targeting region. Now you can guess, I think. Korea, I gave you the hint that whenever there is a national at the first position, then national means it will this program will be implemented across the India, not just for Delhi or NCR. So now you can identify which program are just for Delhi and NCR. I gave you the hint, national are for across the India. Abdul gave me answer C. Korea A. No. Can't you go for D? Because NAMP, monitoring, establishing the monitoring station was established over the India, so it was not just for Delhi. So ANCAP was not the option. Then and sorry, NAMP and CAP we talked about. This is the clean air program. So this clean air program was for all over the India. So the term that has been started with N or the national, so it was for across the country, not just for Delhi and NCR. So if we are talking about Delhi and NCR, except NAMP and NCAP, all answers should be correct. So GRAP, HLTF, CAP should be the right answer. So D should be the right answer. Okay, last question to go. Which app gives the information about the air pollution? Sameer app, Pravan app, Hava app, Swachh app. Come on, guys, this is the last question. Which app can give you the information about the air pollution? The app that has been released by CPCB. CPCB is controlling that app. Korea gave me A answer, Sameer app. Nishant, Jack Krishnan, Abdul. This is the last question. You can tell me. Okay, so answer is Sameer app. This app can give you the information about the air pollution, and this has been released by the CPCB. So thank you so much. If you have any query, you can tell me. If you have any suggestion, how should I go further to teach you? So again, you are welcome, and thank you for being patient from 6 to 8 on Monday. And I hope that you will come again on Monday from 6 to 8. If you have any query or suggestion, you can tell me. Otherwise, you can leave. Thank you, Korea.